If you've ever struggled with delayed or clunky financial dashboards, you're not alone. Parsing through CSV dumps or generating actionable insights on real-time APIs can be a struggle, and today I'm going to show you how to solve that with MongoDB and Apache Kafka. So there's going to be two main parts to our application. First is going to be live data, then historical data. For the live data, we're just generating some random data. It's just going to be the stock price for a fictitious company. And then with that data, we're going to use Kafka Streams to generate an RSI. So an RSI, or a relative strength index, is just a market indicator that you'd use to determine whether a stock is worth buying or not buying. And then as well as that, we're going to have our historical data. So for our historical data, what we're going to do is we're going to have a sample set of just 10 S&P 500 companies that I found on Kaggle. And it's just over a couple of years, but we're going to use that to put into our MongoDB time series collection and run some simple aggregations on it. So we'll have a simple moving average and our exponential moving average. And these are both just ways of analyzing the trends in your financial data and deciding if there's going to be uptrends, downtrends, and to be able to predict that with as much accuracy as you can predict anything in the stock market. But MongoDB has some specific aggregation pipeline stages built in to help analyze this data. So before we get started with the code, there are a few things you're going to need. So first of all, you're going to need Java on your machine. I'm using Java version 21. But you can use a more recent version and they should be compatible going back as far as Java 17. Next, you're going to need Maven. So I'm using Maven 3.9.6, but of course you can use a more recent version if a more recent version is available to you. Next, you're going to need a MongoDB Atlas cluster. So the MongoDB free tier, the M0 cluster, free forever, is perfectly fine for this application. And it's probably the easiest way to get started. After that, you're going to need Kafka. So I'm using Kafka 3.9. If you want to use a more recent version of Kafka, do just pay attention because some of the commands I use at the end to run our application might be different. So once you have all that, we're going to get started with actually creating our application. And to do that, we're going to use Spring Initializer. So for those who don't know what Spring Initializer is, it is just a simple web app used for creating your Spring projects. It helps you just configure the project and bring in any dependencies that you need. Now for this, what we're going to go over is some of the important stuff first. We have our project and we're going to be using Maven. After that, we have language is Java, and the Spring Boot version I'm using is 3.5.3. That isn't the only one you can use, but whatever you're using, just do pay attention. It can change the versions of the dependencies coming in. After that, we just have our group name. So I named mine com.mongodb and the artifact financial aggregator. So that just means our package name will be com.mongodb.financial aggregator. Now, after that, we have our packaging. So we're going to package this as a jar, and like I mentioned earlier, I'm using Java version 21. Now, we need to bring in our dependencies. So first things first, what we will be creating is an API. So we're going to bring in Spring Web. After that, we're going to be using Kafka. So if I type in Kafka here, first you'll see Spring for Kafka. This is going to be necessary for the publish and subscribe that we're going to be using. And then as well as that, we are going to be using streams. So if I type in Kafka there as well, you will see the stream processing dependency. And last but not least, we will be using Spring Data MongoDB. So if we type in MongoDB, we don't need the vector database for this one. That just comes with Spring AI. We don't need the reactive, we need Spring Data MongoDB. Now with these four dependencies, we are ready to hit generate and create our application. This will just download a zip that we can open in the IDE of our choice. So with our application created in Spring Initializer, we do need a database to connect to. So I'm doing this in the Atlas UI. There's nothing stopping you from doing this using the Java driver, but I just thought this would be easier to follow in a video. We are starting with a empty M0 cluster. So in here, I'm just going to hit add my own data, and we're going to start by specifying a database name for storing our data. So I'm going with stock_market_data, and we'll start with our live data. So I'm going to go with live_data. Now, under additional preferences, we want to set this as a time series collection. A time series collection is optimized for storing and querying timestamp data. So in order to do this, we are going to need to specify a time field. We haven't seen the model for our data yet, but our time field is going to be date. It's just important that this time field is a BSIN data type. Now, underneath that, we can leave the meta field blank. That is just a way for grouping your data, and it should be a way for just uniquely identifying a related group of documents. We'll use it in our historical data. And then again, for expiry after seconds, that just means that if our documents are stored in the database, we want them to expire after a certain amount of time. We can of course stick with granularity seconds, and then we don't need to touch any of the bucket parameters. If we hit create on this, up next we are going to make our historical data. So I have a historical data set that I got off of Kaggle, and that just contains a bunch of S&P 500 companies and their reporting over a couple of years. So this collection we're going to call historical_data, and for additional preferences, it's going to be a time series collection again with the time field of date. And this time we are going to add a meta field for company. So this will create a compound index on the date and company fields and allow us to just efficiently query by those two fields. Now we can create this one as well, and we'll let this spin up. So with these two created, we are going to need to connect to the database. And to do this, we're going to head over to Overview, and we're going to get our connection string. So if we hit connect, go to drivers, I have the Java driver selected, and we're just going to copy this here. So the only thing we'll need to do is you'll need a user that can access this database, and you're going to swap out the username and password here in the connection string. So once we have that, we're done here, and we can go over to our application. So for this tutorial, I already have the application created. It's quite a large application with a few moving components. So what I suggest doing is following along. I'm going to give explanations for all the code. I'm going to show you where everything is, what it all does, and then I also have the GitHub repo linked down below. So if you want to copy and paste from that as you're following along, that's probably just a little bit easier than trying to follow me typing. Now, as well as that, I also have the written tutorial for this linked down below. It has all the code snippets and follows along chronologically as we introduce them. So if there's anything you don't understand, maybe the written tutorial might help you there, or you can drop a comment down below, ask any questions, I'll be there to answer them. Now, first things first, what we're going to do is we're going to bring in that connection string that we just got from the Atlas UI. So to do that, we're going to go into resources, and we have application.properties, and in here we have our spring data.mongodb.uri, and I just set an environment variable here for MongoDB URI and have that pasted in here. And underneath that, I just also specified our database. For this, it's spring.data.mongodb.database, and it's that stock_market_data database that we just created in the Atlas UI. With our MongoDB connection string added, the application is now wired up to our database. MongoDB Atlas will act as our primary data store for both real-time and historical market data. From here, we're going to break the tutorial into two main parts. First, we'll look at the real-time data pipeline, how we simulate livestock data, stream it through Kafka, calculate real-time indicators like RSI using Kafka Streams, and store everything in MongoDB. Then in part 2, we'll shift gears to historical analysis. I'll show you how to load historical stock prices and run real financial calculations, like simple and exponential moving averages, directly inside MongoDB using MongoDB's aggregation pipelines. So let's start with the live data model. If we go into the model package, and we can open livestock data, this is the livestock data class. It maps directly to our time series collection in MongoDB called live_data. We've annotated the class with @timeseries at the top. This allows us to denote this as a model that represents a document in our MongoDB collection live_data with the time field date. The rest, open, close, high, low, volume, is pretty standard for stock tickers. We do have the @ID up here, which indicates which of our fields is going to be used as the ID field in MongoDB. It will be _ID in MongoDB. We've also reserved a spot for RSI, which we'll calculate later using Kafka Streams. The rest beyond this is our simple constructors, everything we need, getters and setters. Now that we have our data model defined, let's walk through how the data actually flows, starting with Kafka. So that's our model defined for our live stock data, or our live financial stock data. Let's start talking about Kafka. Kafka is our backbone for streaming data. We use it to decouple the generation of stock data from the processing of it. So our simulated stock prices get published into a Kafka topic called stock-prices. That topic is just a buffer, a stream of incoming events, but we're not just reading the messages one by one with a consumer. Instead, we're using Kafka Streams. Kafka Streams is more than just a listener like the consumer is. It's a full stream processing library. That means we can hold state, perform rolling calculations like moving averages, and react to the data in real time. It's exactly what we need to compute RSI on the fly as prices stream through the system. Let's start by setting up the producer in our Kafka producer config class. So this is in the config package of our project, and we're going to go to Kafka producer config. So in here we need to define two beans. We need to define the producer factory bean and the Kafka template bean. The producer factory defines how we serialize the data. Our keys are plain strings, and our values are livestock data objects. We use JSON deserializers so we can send rich unstructured JSON into Kafka. And Kafka template is Spring's abstraction that makes it easy to send messages programmatically. So breaking down some of the configs we have in here a little bit more, you'll see that we're working on the localhost 9092, and below that we're setting up the serializers for our key and value using the string serializer and the JSON serializer respectively. Next, we also need to create a custom survey. So if we go into our utility package, you'll see we have a live stock data survey. Survey is short for serializer deserializer, and it's for a stream processor. This just tells Kafka Streams how to convert our raw bytes into usable livestock data objects in our application, and vice versa. Without this, Kafka wouldn't know how to interpret our custom Java objects in the stream. Finally, we set up Kafka Streams runtime itself in a Kafka Streams config. So this class is up with our Kafka producer config in our config package, and this is where we configure how the processor runs. So this class here we are defining as a configuration class, and we are giving the annotation at enable Kafka Streams. So on the Kafka Streams config, we have our bean here, Kafka Streams configuration. And there's a couple props we add for configuration. So first of all, we do have the application ID config, which is just a unique identifier for our stream app. Kafka uses this to track state and offsets. We also want to give our port address, localhost 9092. Our streams config default key survey class config just takes in surveys.string.getClass, and this just says we expect keys to be using strings. And under that, of course, we have our JSON deserializer. So this ensures Kafka Streams knows how to read our custom livestock data objects. This config is what activates Kafka Streams engine inside our Spring Boot app, and once it's running, we can define stream topologies, transformations, and logic for how to handle incoming stock data. So that's how we're going to add our RSI or any other computed values we wanted to add to our livestock data streaming in. So at this point, we're ready to start producing stock data in Kafka, and we've laid the foundation to process it in real time with Kafka Streams. Next, let's hook up the actual simulation logic and start publishing stock data into Kafka every second. Okay, now that our Kafka config is in place, we need something to feed data into the system. We're not using a real stock API, just a lightweight simulator to keep this demo self-contained, but there's nothing stopping you from adding a real API here. I'm not going to claim this is the most accurate market simulator in the world. It's not, but it gets the job done for this. In our service package, I have a class here called Simulate Live Data. In our Simulate Live Data class, we generate daily stock data for a fictional company called Doof. Each data point includes open, close, high, low, and volume, just like a real candlestick chart would need, and this maps directly to our livestock data model. The logic uses a trend slope that gently increases or decreases over time, with some sine wave oscillation to add a realistic market rhythm and a bit of randomized volatility. Every 60 days or so, it flips direction just to keep the trend from going to zero or hitting the moon. So you can see here some of my logic. None of it's perfect and it all works with just some magic numbers, but it does give us enough information to plot in our chart and to calculate some interesting insights on this fictitious data. After generating the data, we send it into Kafka using Kafka template. We key it by company symbol and we send the full stock object into our stock prices topic. So to do this, every 1 second, we use the @scheduled annotation. And what we do here is we just have our livestock data where we create an individual livestock data object, and then we send this onto the stock-prices topic with the company and the data as the key and the value. As well as this, I did include just some very, very mild error handling and then some logging just to keep something going in the terminal so you can see it working. Now to get this all working in our application, we do need to add one thing to our main application class. So in Financial Aggregator application, we need to add the annotation enable scheduling. This is just necessary to allow us to simulate this running every 1 second. And if you want to increase how often it goes, decrease how often it goes, it is just playing around with that annotation at the top of this method here. With this in place, our application now generates stock data on the fly and pushes it into Kafka ready to be processed in real time. Next, we'll look at how we're going to consume that stream, calculate the RSI, and store enriched data in MongoDB. If you're not familiar with RSI, the Relative Strength Index, it's a momentum indicator used in technical analysis. It measures the speed and magnitude of recent price changes to detect overbought or oversold conditions. It's typically plotted as a value between 0 and 100, and traders use it to identify momentum shifts. To save each enriched data point, we use Spring Data's Mongo repository interface. So I have that in my repository package, and here we are going to go into our live data repository. Now, this looks super simple, it's because it is. This gives us instant CRUD interface, no boilerplate required. We just create the live data repository that extends Mongo repository. We add in the fact that we're going to be working with our livestock data model and our object ID. It takes care of everything else under the hood. So because we specified earlier that our livestock data is using the collection live_data, whenever we read, update anything, it's going to know automatically that that's the collection it's interfacing with, and it's able to infer the CRUD With this in place, saving new stock data in MongoDB is as simple as calling .save data on our live stock data. Now let's calculate RSI. So we define a utility class called RSI calculator in our utility package, and in here it's just a simple formula. It takes a list of closing prices and a period, usually 14 days, and returns the RSI using the standard formula. If prices have only gone up, RSI will return 100. If they've dropped sharply, the value moves closer to 0. It's a rolling signal that helps us understand momentum in the market. We're going to use this in our Kafka Streams pipeline in a class that we've defined as RSI Stream Processor, which is in our service package. So the RSI Stream Processor, it's annotated as a component, and in here I have hard-coded the RSI period to be that 14 days. Inside it, we built the stream topology using Streams Builder. We read from the stock prices topic using our custom live stock data survey to deserialize incoming JSON into Java objects, as you can see here. And then in our stream.peak, we use peak to inspect each message in the stream. For each stock tick, we first validate the data is present, then we pull the closing price and add it to the rolling window. We keep this window in memory using a simple dequeue. Once we've collected 15 days worth of prices, we calculate the RSI and attach it to the data object. Finally, we can just call our live data repository with the .save data method, and this will add our livestock data to our database containing that RSI calculated value. This gives us a fully reactive stream from generation to transformation to persistence. Every second, a new price is generated, RSI is calculated, and the enriched data point is stored. No polling, no batch jobs, no external scheduler, just clean, continuous flow. Now, in order to expose this, I created a controller class that just outlines an API. So this API I've hooked up to a front end, and we're not going to get too deep into the weeds on it, but I'll just go through which endpoint we're using and when. So here we are doing our live data, and that one's all the way at the end, and you'll see it just goes to our localhost 8080 stocks live. And this can be retrieved with a curl request, or you can connect it to the front end that I'm going to provide in the GitHub below that just lets you interact with the application. Next, we're going to look at exposing this live data through an API and take a look at how we can query our historical stock performance using MongoDB's aggregation framework. So to do this, we need to set up a service and a controller. We're going to expose a simple REST API so that our front end or any other service can access the latest stock data and indicators. We start with the basic service class, so I have financial service class in our service package. Don't worry about everything going on in here, we'll be adding stuff as we go along. What we do want to pay attention to is we have our live data repository that we're bringing in. What we do need to worry about is our get live data here that I have at the bottom. And what this does is inject our live data repository and expose a method called get live data. So behind the scenes, that just runs a find all on the live data collection, nothing fancy, it's just Spring Data doing what Spring Data does best and abstracting away the domain specific stuff. We can just interact with this like any database in Spring. Next, we're going to need our controller. So I have financial controller here in our controller package, and there's a lot going on here. Don't worry, again, we're going to be defining stuff as we go through. What we're just going to pay attention to is our get live data at the bottom. So this is the entry point for our HTTP requests. So we map everything under the /stocks at the start. That's all the way up here, but that's just going to be our path. We are going to allow a cross origin. This annotation just allows our front end environment to interact with this without giving any CORS errors. So going back to the end of our REST controller, it's a simple /stocks/live that doesn't take in any parameters, but what it does is it will run that find all on our livestock data collection and return all of the documents that we have there. So just to recap, we're now fully end-to-end. We simulate stock data, stream it through Kafka, calculate RSI in Kafka Streams, save it to MongoDB, and expose it through clean REST API. But that's just the live data. Next, we'll dig into historical stock prices, how we import thousands of real records and use MongoDB's aggregation framework to calculate SMA, EMA right inside the database. In this section, we're going to import a real-world historical dataset and use MongoDB's aggregation framework to calculate some meaningful indicators on it. So all without leaving the database. To start with this, we're going to need that historical dataset. I've dropped a link down below. It's hosted on Kaggle, and it's just some tickers. And it includes over 25,000 entries for top companies like Apple, Tesla, Meta, spanning over 10 years, and their daily stock price data. So you'll see here at the top of our data set, it just has the company date, the close, the volume, the open, the high, and the low. It mimics our livestock data pretty similarly, but the way we're going to use it is ever so slightly different. To get started, we're going to have to pop up to our model package again, and in here we have stock market data. This stock market data mirrors the structure of our CSV data, and similarly to our livestock data, we annotate it at the start as time series with the collection historical_data. the time field date, and if you remember earlier, we added the meta field company for filtering. This just creates a compound index on the fields date and company so we can more efficiently query our data. To persist this data that we downloaded off Kaggle, what I've done is I've stored it in the resources directory with the name data.csv. That is important if you're copying my code exactly, that it's stored in the same place under the same name. But then we're going to use a new repository. So we create an interface financial repository. So we create an interface financial repository using the Mongo repository interface, just like we did before for our live data. And while we're here, we're going to add a query that fetches stock data by company and date range. We'll use this later to power our candlestick graphs, but while we have this open, it's a nice and simple, it's a list, and we're going to pass in our model stock market data. And using Spring Data, we don't need to do much beyond naming this method using find all by company date between, and it will automatically create the query needed to get this data from our MongoDB database. To load in the data, we use a one-time import that reads in the CSV line by line. To do that, we're going to go into our services, and I have a class called read in historical data. Now I have some stuff commented out here, so if you've cloned this repository, you are going to need to uncomment them out. And it's just at the top, this class implements application runner. So what this will do is when we spin up our application while implementing application runner, it will run load data. And this just parses our CSV file and it goes through, it takes some of the lines into memory, and then it will do a batch import on our data. So I think I set the batches to 500. This just means it will run more efficiently than if you're trying to insert each document one by one. And using Mongo repository, the way you run these batches is with the method save all. Once this has done its job and you've loaded this data into your database, you can actually comment back out the add override and this first line here, public class. And we can go back to just having this as a standard service. And this just means it won't rerun every time we start the app and add in a bunch of duplicate data. So up until now, we have what we need to upload our historical data into our database. And we're starting to get to the interesting part, which is instead of calculating moving averages in Java, we're going to lean on MongoDB's aggregation pipeline, specifically the set window field stage, which supports native window functions. This allows us to compute rolling metrics like simple moving average and exponential moving average directly inside the database. Faster, more scalable, no post-processing required, you're able to control easier what data you're sending over the network. And you don't need to hold all these values in memory in your application while you're doing your calculations. Now that we got our historical data stored in MongoDB, we're ready to do something meaningful with it. Let's get started with actually creating these technical indicators, our SMA, our EMA. And we'll start this by creating a few DTOs. These are just simple records that define the shape of our results. First, we'll have the company DTO, and in this, we're just going to carry the company name. Then we'll have our simple moving average DTO, and in this, we're going to have our double, which is going to be our simple moving average, and the date corresponding to that calculated value. Next, we're going to do the same with our exponential moving average, just with that double for our EMA and the date that corresponds with that value. Next, we need to define a custom repository interface. This is where we declare the methods we'll use to run our aggregations. So in our repository, we have a new interface that we're referring to called custom financial repository. In here, we're not going to be extending Mongo repository like we had done before. We're actually going to be using Mongo template, and I'll discuss more about that in a bit. For each of those DTOs we created, we're going to provide a corresponding method. So first we have our getAllCompanies, that's just going to return a list of the company DTO. Next, we're going to have a getSimpleMovingAverage. That again is going to provide a list of our simple moving average DTO, but this method is going to take in the company, the start date and end date that we're going to use for calculating these values. Lastly, we have our list exponential moving average DTO that we're going to be using in our getExponentialMovingAverage. And again, this is going to take in the company name, the start date, the end date, and we're going to use this information just for plotting it on our front end later. So now that we've seen the methods we're going to be implementing, it's time to actually look at the implementation. So we have a class here, which is just our custom financial repository implementation. And in this, we have a couple of methods. So we're using Mongo template instead of Mongo repository because we're going to be running aggregations, and Mongo template just gives greater control with how you interact with the MongoDB database, and it allows you to build these aggregations. So first of all, we have our getAllCompanies. Now, if you remember from before, in our CSV, we have our companies at the start of each value that's in our database. So each document in our database contains a ticker symbol along with the information for that day. This is a lot of information to get through, and in order to find out how many companies we have in our database, what we have in our custom financial repository is an aggregation that just groups all by company. What we have in our custom financial repository implementation is an aggregation that gets a list of the unique companies by grouping by company and then just sorting by name so it can be a predictable list each time. We then call MongoTemplate.aggregate, pass in this aggregation that we just created, and tell it to return using the company DTO class. The simple moving average method is defined down below that one, and there's a little bit more going on in here. So this method calculates a 4-day rolling average using average across a sliding window. We use set window fields to partition by company, sort by date, and average the close last field from the current document and the 3 before it. The result is a smooth trend line that reduces daily noise and helps plot longer term movement. Each result has a date and an SMA value, perfect for plotting directly on the graph. Just like before with our previous aggregation, we're going to use MongoTemplate.aggregate. We pass in the aggregation pipeline we just created that has the match for each company, the simple moving average operation that calculates using that sliding window, and then a project field, just to say these are the fields that we need to keep from the aggregation. Don't bother sending over anything else other than the SMA and the date. This way, when we call our aggregation on the collection historical data, we can return it all in our simple moving average DTO class that we created earlier. For the exponential moving average, the structure is almost identical, but instead of averaging equally, we use the exponential moving average function, and we use this with a period of 20 days. So this is provided by MongoDB and allows us to perform an exponential moving average function natively in MongoDB. This function gives more weight to recent prices, helping traders spot momentum shifts quicker than with the simple moving average. Again, like before, we're going to be performing this on an individual company, so we have the match, followed by the EMA operation, and then we project the fields we need, so the EMA and the date as a date. And we call that with MongoTemplate.aggregate with our aggregation on historical underscore data and exponential moving average DTO. It's getting repetitive, it's nice and simple. To connect everything to our API, we wire up these methods in our financial service class. So like you might have seen earlier when I was scrolling through, we have our methods here that implement these custom financial repository methods. And we now support fetching the raw historical prices, calculating the simple moving average, the estimated moving average, listing all companies, and of course accessing our live data from Kafka. Each of these new methods is exposed in our controller. So like I scrolled past earlier in our controller, we have all of these defined. Now, a few of them, like you saw earlier for our exponential moving average and simple moving average, we require the parameter of the company and the start date and end date. This just means when we're plotting the graph, we're not plotting for the whole time frame, we're just plotting for a set start date, end date, and those are the only estimated moving average, simple moving average we want. So that's the same for the simple moving average. And then for getting the stock between dates, it's just a way for displaying the data a little bit nicer on our graph. With this setup, all the real work happens inside MongoDB. We let the database handle filtering, sorting, and the windowed math, so our app stays fast, clean, and ready to scale. So now that we have all this, it's time to actually run our application and run Kafka, so we can see everything working together. In order to run our application, we're going to need Kafka running in the background first for our live data. To do this, we're going to start by choosing our UUID for our cluster. We can also generate one. Now, in order to generate one, we can do it like this, which I'm just going to paste a command on screen. That is going to be in the tutorial that's linked down below. And it's just cluster ID equals, and then we generate our random UUID. And once that has run, we can get our cluster ID. We can view it just using echo, and we can see it's been assigned. Now, up next, we need to format kraft. So this is the command we need to be running, and all of these commands do need to be run wherever you have Kafka downloaded. And I mentioned at the start, but do pay attention to what version of Kafka you're using. If you're using an older version with Zookeeper, the commands will be different. And I believe for some of the more modern version of Kafka, if you're 4.0 over, you might need to be running different commands, but I'll link below the Kafka documentation. So hopefully there's no issues. If there is anything, just drop a comment down below. So this command is just there to format the kraft storage. This writes metadata to the log directory and makes the broker startable. So now it's actually time to start a Kafka server. So to do this, we have one more command to run. And if everything's going correctly, we should see logs. Something similar to this, basically just saying Kafka started. And we can now run our Spring application. So I'm just going to open up IntelliJ again. But before I do, we're going to look in my MongoDB collection and we're going to see that we do have just 2 empty collections with nothing in them. And if I go back over to IntelliJ, I can start up my application. And if everything's going well, we should start to see some of the logging I added earlier. That's saying, yep, we're generating our documents like we were supposed to, and they're being received by Kafka. Now, if we go back over to our MongoDB database, our live data might start, yes, our live data is populating first, and you'll see some of the earlier values don't actually have an RSI because there's not enough historical data to calculate it. that's absolutely fine. It will jump in at some point. Once we have, I believe it's 15-day backlog. And then for historical data, it does take a little bit longer to load in just because we're loading in those batches. But once that's there, I'm going to spin up our front end and we can have a look at that application that I demoed at the start. And as you can see here in the live data, we have a simulated graph just of our stock prices growing, declining, and then that RSI being projected over on top of it. And I just have it updating very occasionally. And as well as that, I provided some information on what's being calculated, as well as the relative or the most recent relative strength index for each stock or for each day. And if we want to look at the historical data, over here we can select company. And if we look at, let's look at Netflix. They were doing quite well for themselves. And again, just like before, we have those stock prices with the information. I'm plotting the high, low, close, and the open, and then I also have the simple moving average and the exponential moving average just graphed in their respective colors, so orange and blue. So now you have a fully functional real-time market data aggregator built with Spring Boot, MongoDB, and Kafka. It handles streaming, processing, and storing your data efficiently, and if you want to check out the application, the GitHub link is just below. That contains the Spring Boot application that we built here, as well as the React Vite front end that I put together just for some demo purposes. If you found this useful, make sure to like and subscribe. And if there's anything else you want to know in the MongoDB Java world, leave a comment, put in your requests, and I'll try to answer it all.